So I'm going to read this one out. I don't remember exactly what I say here, so let's see how it goes. When solving quantum field equations, or whatever, they found that electrons send out and absorb virtual photons, and this affects the electron's effective mass. They found that when trying to correct for this, electrons have an energy replenishment quality because mass is energy, called self-energy. But it turned out to be infinite mass, and they didn't, when they tried to correct for it, they found it to be infinite mass, and they didn't like that because, electrons, we've measured their energy, they're in their mass, and it's not infinite, right? We have a measured value for it, so there must be something wrong there. But what if that infinite number is over time and not at an instant, right? Because as I've been saying in a lot of my videos, dark energy is all around, and these electrons, or really just particles in general, are taking energy in, and they're taking in this dark energy, right? And they're using that to sustain their energy because they're constantly also sending energy out. All these particles are radiating these virtual photons. We don't necessarily see them. Like, we have this term virtual in front of it. They're not virtual. This is real. This is happening. Just because we can't observe it doesn't mean it's not there. And we found that they can absorb these virtual photons and get energy from them. So if they're getting energy from these photons, right, then they're not virtual. They're a real thing. They're there, and we found that they can self-sustain themselves. They can create self-energy. And that's exactly what I've been saying. It's kind of crazy that I've been going through now, and I'm going from thinking I'm weird and I have these weird concepts, right, to finding out that all the concepts that I've come up with are still are like a thing. They just haven't been fully fleshed out. And I've just been connecting so many dots here, and every time I find something new, I'm like, there it is, another thing that makes total sense from my perspective, right? And when you've developed a model and anything you pointed at, it just works, it starts to make you wonder, how crazy you really are, right? And that's pretty much what's been happening with me. So, maybe I just created a system that can't be proved wrong because of how I developed it, or maybe I'm just completely right. Who's to say? I don't know. Anyway, they found that when they try to correct for this, electrons have an energy replenishment quality. What if over time it's, basically what I was trying to say before I sidetracked myself is the mass of the electron kind of is infinite because it's constantly replenishing itself. And so in theory, the electron doesn't just run out of mass, but it's not a constant value because mass is energy. And we know that energy is not conserved in our universe. And we know that electrons are constantly taking in and emitting photons. How could they possibly be taking in and emitting photons but still maintaining their energy, right? They have to maintain their energy somehow. We know that they have an energy, they have a mass. We've measured it. It exists. But from a logical standpoint, we should observe the decay of an electron. And I don't know if they do that. I could be wrong. Maybe they do. But if they do decay, right, they still decay into other objects of mass, and then we should observe those things decaying. And I don't know if that's necessarily what we see. Basically, these electrons sustain themselves. And if they do decay, it's not fast. It's not a fast decay thing. Maybe it's a spontaneous decay thing. I don't know electron decay, if that's a thing at all. I don't think it is, but I could be wrong about that. This makes sense though, because it comes from dark energy, which means its source should be seemingly infinite. And so they are sustaining themselves, and it seems like this self-energy is in infinity, and it shouldn't be there, but it should be there, and it's true, because it's not that it has infinite mass currently, but it does have infinite mass because it is constantly getting fed. It's like putting, turning on your sink, right? And then measuring the amount of water that is coming out of the faucet down to the sink basin, right? That distance of water, that is your mass, right, of the electron. But that mass, that water, right, is not the same from instant to instant. And it would seem, and it keeps flowing, and it's constant, it's the same value, but it is a seemingly infinite mass, because the mass is constantly replenishing itself, even though the value is staying constant, but the mass that was coming out of the faucet at one point is now going down the drain. And even though that's the case, there is still more there, but it's still constant, right? And that is the effective mass of the electron. And so, the faucet, or where the water is coming from, is this dark energy source, and the drain is the radiation of, these virtual photons by particles, because it's not just electrons that do this, but that is kind of the mechanism that's happening here. And I'm seeing, we're trying our best to try and explain it, but when you understand what dark energy is, and you tie that into the fact that energy is not conserved in our universe, but we still have so much energy here, right? And you tie that into just how, I think the biggest problem why no one accepts this is because no one believes that there could be some kind of energy conversion mechanism in something so small. But the fatal flaw in that line of reasoning is in assuming that you're, normal size. I guess is a good term. To assume we are the standard is the same as assuming we're the center of the solar system, right? To assume that where we are on the scale of things is right in the middle is absurdity, and it's hubris. There's no logical reason to conclude we are the middle of the scale. We could be anywhere on it. There could be no end. It could be infinite in both directions, right? So in that case, it really doesn't matter where we think we are, because no matter where we are, there's infinite in both directions, right? And I think that may be a potential. I really don't think it's safe to rule that out, but it's important to understand that just because we are too large to observe and calculate and quantify these values, they get so tiny that the numbers just are meaningless and are effectively zero. Just because that happens for us does not mean that happens for the particles that are that size. Because they are that size, right? For them, for a particle that is that size, we are not even comprehensible, right? A particle at that size would look at us and see nothing but a void. And I think that kind of viewpoint is extremely important. Just like the Planck constants, all the Planck constants and all these limitations on physics is a limitation on our physics, not on the objective laws of the universe. There is no reason why it should stop where we can't observe. There's no logical reasoning for that. That is the hubris of humanity and the need to feel important, to feel relevant. And yeah, I don't know if I had anything else to say on that one. Yeah. All right. Peace out.